So, hi guys. In last class, we have studied about onboard communication interfaces. In today's class, we're going to study about external communication interfaces. So, in external communication interfaces, we're going to read about the communication interfaces which we're going to use in our day-to-day life. So in that first one, we're going to see RS-232 and RS-485. So by seeing this diagram, you might remember some of the ports which you guys will going to see in your desktop or in your laptops or in your any of the devices which will be having this kind of ports. So what do you mean by this? I'm going to explain now. So this RS-232C from the Electronic Industry Association. So it was developed by Electronic Industry Association, that is EIA. So the RS-232 interfaces is developed by EIA, Electronic Industry Association. So as per the EIA standard, a logic 0 is represented with voltage between +3 and +25 volt, and the logic 1 is represented with voltage between -3 and -25 volts. So the RS-232 interface defines various handshaking and control signals for communication apart from transmit and receive signals for data communication. So here this RS-232 supports two different types of connectors. One is DB9 and DB25. So this DB will be having of 9 pins, and whereas this DB25 will be having the 25 pins. So next we're going to see the USB, where we're going to use this USB. You guys will be knowing we will be using this USB cable in daily we're going to use. We're going to connect my USB cable for charging. We're going to connect my USB cable to my laptop, to my phone, in order to transfer our data from a laptop to mobile or mobile to my laptop, etc, etc, etc. So now we are going to see about this USB. What do you mean by this USB? USB is abbreviated as Universal Serial Bus. It's a wired high-speed serial bus for data communication. So the first version of USB was released in 1995. So the USB communication system follows which topology? So it follows a star topology. So USB 2.0 host can support up to 127 devices, including slave peripheral devices. So who will going to initiate the communication here? So the USB host will going to initiate a communication in order to communicate between these peripherals. So USB transmits data in packet format. So there are different standards for implementing the USB host control interface, namely OHCI, that is Open Host Control Interface, and UHCI, that is Universal Host Control Interface. So the physical connection between a USB peripheral devices and a master devices is established with a USB cable, as we guys know. So the USB 2.0 standard uses two different types of connectors. So that is a type A and type B. What do you mean by a type A? A type A connector is used for upstream connection. So that is, upstream means connection with the host, and type B connector is used for downstream connection, that is connection with the slave devices. For example, the USB connector present in a desktop PC or a laptops are example for type A USB connector. So both type A and type B connectors contain 4 pin for communication. This is what about the USB. So next we're going to use IEEE 1394. So IEEE 1394 is a wired isochronous high-speed serial communication bus. So the research on 1394 was started by Apple company, that is Apple Inc., in 1985, and the standard for this was coined by IEEE. So in 1394, so 1394, that is IEEE 1394, supports peer-to-peer connection and point-to-multipoint communication allowing 63 devices to be connected on the bus in a tree topology. So there are two differential data transfer lines. So the data transfer lines and the interface cable supports three types of connector, namely a 4-pin connector, 6-pin connector, and a 9-pin connector. So next we are going to see about infrared. What do you mean by this infrared? So infrared is a serial off duplex communication which you're going to use in a wireless technology. So what do you mean by this off duplex? Off duplex means one-way communication. So the infrared is in the use of from the olden days. So infrared communication technique uses infrared waves of the electromagnetic spectrum for transmitting the data. Infrared supports point-to-point and point-to-multipoint communication, providing all devices involved in communication and within the line of sight. So that means which is inside this infrared region. So the infrared lies, the range will be from 10 centimeter to 1 meter. So next we're going to see about Bluetooth. So what do you mean by this Bluetooth? So Bluetooth is a low cost, low power, short range wireless technology for what? For data and voice communication. So Bluetooth was first proposed by Ericsson in 1994. So Bluetooth operates at 2.4 gigahertz of radio frequency spectrum and uses FHSS, that is frequency hopping spread spectrum. So like infrared, Bluetooth communication also has two essential parts. One is physical link and second one is protocol part. So what this physical link will going to do? So the physical link is responsible for physical transmission of data, whereas the protocol part is responsible for defining the rules of communication. So each Bluetooth device will have 48-bit unique identification number. So Bluetooth supports point-to-point and point-to-multi-point connections. So Bluetooth range is of 30 feet. So next we're going to see Wi-Fi. So Wi-Fi or wireless fidelity is the popular wireless communication technique for network communication devices. So Wi-Fi follows the IEEE 802.11 standard. So Wi-Fi based communication required an intermediate agent called Wi-Fi router. So the Wi-Fi router is responsible for restricting the access to a network, assigning IP address to devices on the network. So Wi-Fi enabled devices contain wireless adapter for transmitting and receiving data in the form of radio signals through an antenna. So for communicating with the devices over a Wi-Fi network, so the device, when it is in Wi-Fi radio, is turned on. It searches with an available Wi-Fi network in its range and lists out the available Wi-Fi's by using service set identifier, that is SSID. So if the network is a security enabled, we need to give a password in order to connect to my Wi-Fi. So Wi-Fi employs different security mechanisms like wired equivalency privacy, that is WEP, and WPA. WPA is wireless protocol access. So this is what the Wi-Fi is, and it supports a data ranging from 1 Mbps to 150 Mbps. So next is ZigBee. What do you mean by this ZigBee? So ZigBee is a low power, again a low cost as that of an infrared and a Bluetooth. So ZigBee is targeted for low power, low data rate and secure applications for wireless personal area, that is WPAN. So wireless personal area networking. So ZigBee supports an operating devices of up to 100 meters and a data rate of 20 to 250 kbps. So here ZigBee consists of three, that is ZR, ZC and ZED. So first we're going to see ZC. ZC is nothing but an ZigBee coordinator or network coordinator. What's the function of this ZigBee coordinator is ZigBee coordinator acts as the root of the ZigBee network. So the ZC is responsible for initiating the ZigBee network, and it has the capability to store information about the network. So what about ZR? So ZR is ZigBee router or full function device. It also called as a full function device, which is responsible for passing information from a device to another device. So next we're going to see ZED. ZED is ZigBee end device, which is also known as reduced function device. So this end device containing ZigBee functionality for data communication. So it can talk only with ZR and ZC and does not have the capability to act as a mediator for transferring a data from one device to another. So this ZED does not act as an intermediate between these devices, whereas ZR and ZC will be acting as an intermediates in order to transfer data to other devices, whereas ZED will not going to act like that. So this is what about ZigBee. So next we're going to see other system components. So other system components, in that first we're going to see the reset circuit. So the reset circuit is of two. One is active high and another one is active low. So the reset signal can be an active high when the processor undergoes reset, when the reset pin of the processor is at logic high. So when the logic high, this will going to make the circuit reset. So what this will going to do? So this will going to do when it will going to reset the circuit when the logic is low. So this is what the reset circuit is of. So next we're going to see brownout protection circuit. So brownout protection circuit prevents the processor from unexpected program execution. So here in this we have the Zener diode DZ and the transmitter Q. So these two, the Zener diode and the transmitter, forms the heart of this circuit. So the transistor conducts always when the supply voltage VCC is greater than that of sum of VBE and VZ. So when this transistor will going to conduct, so when it will going to conduct when the sum of VBE and VZ should be greater to a supply voltage. So here the transistor stops conducting when the supply voltage falls below the sum of VBE and VZ. So this is what about brownout protection circuit is of. So next is oscillator unit. So this is this oscillator unit. Wait a minute. So oscillator unit is a digital device made up of digital combinational and sequential circuit. So here a certain processor or a controller integrate a built-in oscillator unit and simply require an external ceramic resonator. So this is what the external ceramic resonator is of for producing necessary clock signal. So its duty is to produce a clock signal. So here in this, we're going to use this resonator and the capacitor in order to produce the clock signals. Whereas here in this, if we're going to use the clock input pin to this oscillator unit, which will going to produce the clock pins for this oscillator unit. So I'm going to explain in detail. So certain devices may not obtain built-in oscillator unit and require the clock pulses to be generated and supplied externally. So the speed of operation of a processor is primarily dependent on the clock frequency. So here it is. So next is RTC. So I have forgot to include that RTC slide in my PPT. So what do you mean by this RTC? So RTC is a real-time clock system, is a component responsible for keep track of time, data, month, year, day of the week, etc. See, for example, in your laptop will be, even in your off state, it will going to show the correct time, correct date, correct month, etc. Correct? So that is what the real-time clock is of, RTC is of. So RTC is intended to function even in the absence of power. So the RTC chip contains a microchip for holding time and date related informations. So for operating system based embedded devices, a timing reference is essential for synchronizing the operations of OS kernel. So that is what it will be done by this RTC. So RTC mainly will keep track of date, time, month, year, etc. So next we're going to see about watchdog timer. So what do you mean by this watchdog timer? In a desktop Windows, in a desktop, keep it in mind, in a desktop, if we feel our application is behaving abnormally, what we're going to do? We're going to press Alt Control Delete to come out of the situation. So what about in this watchdog? So the watchdog will going to perform same in embedded systems. So what it will going to perform? We're going to see. So watchdog, here it will going to monitor the firmware execution and reset the system processor. So when the program executing ends up, a watchdog timer, uh, the watchdog timer will going to monitor the firmware execution depending upon the internal implementation. So the watchdog timer increments or decrements a free running counter. Free running, so it will going to increment and it will going to decrement the free running counter with each clock pulse and generate a reset signal to reset the processor. So if the watchdog counter is in enabled state, so the firmware can write a 0. So that means it will going to start counting from 0. So if it is in disabled state, it will going to start count from 1. So that's what the watchdog timer is of. So if the processor or the controller doesn't contain a built-in watchdog timer, the same can be implemented using an external watchdog. So this is the external watchdog timer IC. So the external watchdog timer uses hardware logic for enabling and disabling. So resetting the watchdog count will be done by using a watchdog timer which will be built externally. This is what the watchdog timer is of. So thank you guys. This will going to end your module 3 and we're going to start the module from the next class. Thank you guys.